So good evening everyone, bonsoir à tous et à toutes, and welcome to tonight's presentation of OTF Connex on creating a thinking classroom for primary mathematics. That will be the part one, and it's presented by Laura Ginny Newman. We have a very large group tonight with mostly about half and half experienced users and new participants from throughout the province. It's always truly inspiring to see so many enthusiastic teachers from all across the province sharing their ideas and supporting each other as they discover new and exciting things. We are definitely thrilled to have each and every one of you with us tonight, and it's also an absolute pleasure to welcome Laura Ginny Newman. Laura is a member of the Critical Thinking Consortium, also known as TC Square. She's currently working on the development of a number of resources to support the implementation of critical thinking in the teaching and learning of mathematics. If you attended some of her OTF Connex presentation last season, you will certainly appreciate the privilege of having Laura with us again tonight. Le langage de mathématiques est souvent décrit comme étant le langage le plus universel. I can certainly see people of various backgrounds amongst us tonight, and presumably of various mother tongue. Je voudrais profiter de l'occasion pour souhaiter la bienvenue à nos collègues franco-ontariens dans la langue de Voltaire, ou plus précisément dans celle de Gabriel Roy. Cette session est en anglais, mais si vous désirez obtenir des informations en français, surtout n'hésitez pas à nous contacter par la suite. So, at this point, I'll pass the microphone to Laura to let her keep introducing herself and dazzle us in the universal mathematical language we all share. So Laura, please feel free to click on your talk button now to turn it on, and go ahead anytime you wish. The class
Thank you,
is now
Michelle,
yours.
and good evening, everyone. I'd like to also express my gratitude to have all of you join us this evening. I know it's late in the evening and you're taking your personal time to support the teaching and learning of mathematics, something that's dear to my heart, and so I'm very pleased to be helping you and working with you in this area. Before we begin, I would like to very quickly find out, I know it's a primary session, but I'd like to very quickly find out how many of you, if you can use the chat box, and just type in the letter K if you're a kindergarten teacher, or the numbers 1, 2, and 3 if you're a grade 1, 2, 3 teacher, and it'll give me a sense of who's in the room. Well, thank you, everyone, and welcome. It looks like we've got a pretty even split right across the grades, and we have some instructional coaches and resource teachers who have joined us as well. So welcome to you as well, with some pretty large portfolios. So I look forward to helping all of you out in the implementation of creating a thinking classroom in the primary mathematics, for primary mathematics. And I would like to begin by setting the context, and in doing this, I have actually two objectives. One is to introduce, for those of you who haven't done any work in critical thinking, to introduce you to the concept of critical thinking from a professional learning perspective, and secondly, to have us thinking about why it might be important to create a thinking classroom with our younger children, because often we think there's often a misconception that young children are very innovative or very creative, they love to explore, but perhaps they're a little bit too young to be engaged in formal thinking, particularly in mathematics. But my experience has shown, working with schools right across the world, teachers right across the world, across all the grades, that it's actually our youngest children who are most intuitive in their ability to do this. So I look really, really forward to sharing this, but having you explore and think about how important you would think it is to create a thinking classroom in primary mathematics. And with that in mind, what I'd like to do is related to that question, related to a critical thinking question I've asked you to respond to, I have a task I'd like you to consider as well. And by the end of the session, I'm hoping that you'll be able to think about how you might convince a colleague or your boss of the degree to which a thinking math classroom is needed for primary students, and what you would say in under 2 minutes. So what are the really important things that you would share? I'd like to give you a moment to think about that, but before you do that, I'd also like to introduce some criteria that might help guide your thinking initially around what makes evidence to support creating a math thinking classroom most compelling. And the criteria that I'm going to offer you for this evening is to what degree is it informative? So the thoughts of these experts who are talking about whether we should or should not include thinking in a math classroom, are their ideas highly informative? Do they provide new insights for us as teachers of primary students? And are they convincing enough to actually encourage us to change our practice? So those are the 3 criteria that I would like you to consider. And as well, I hope that you've received this, but I've also created a thinking organizer for you to help you organize your thinking. So thinking organizer here, you will see, has a various sources that we are quickly going to review as an opportunity for you to gather evidence of the ideas that are coming from those experts, from those sources, and then the assessment of that evidence using the criteria that I just reviewed with you, and then an opportunity for you to think about the impact on the response to the question, how important is it to create a thinking classroom in primary mathematics? And you'll notice here you've got 3 options. Is it of little importance, somewhat important, or very important? So what I would like to do is encourage you to take a minute, and I'm sure Michelle's going to use a timer to allow you to do this, but take a minute and think at this point about where you stand on this particular issue. How important is it, do you think, to create a thinking classroom with our younger children when they're learning mathematics? So if you could take a minute to think about that. Do you think it's of little importance, somewhat important, or very important, and why do you have those thoughts?
Okay, I'll start at the timer, so you have a minute to answer in the chat box below. So hopefully everyone's had an opportunity just to at least identify where they stand in terms of this question, and hopefully jotted down some of the reasons why you hold this position at this point in time. And given that, we're just now going to move forward and start looking at the various sources. And we're going to do this relatively quickly because this is really to set the context, and I do want to get to what this really looks like and sounds like in a primary classroom when we try to implement and try to create a thinking classroom with these younger children. So the first source I titled The Mystery and Magic in the Learning of Mathematics, and I'm going to be a little bit of a primary teacher as we do this, but I'm going to read it aloud to you as we go through it. And I'll tell you a little, before I do that, I'm going to tell you a little bit about the source. This is a quote taken actually from a conversation that I recently had with a professor out at the University of Calgary. And he's a mathematics professor, so he, for the most part, teaches university students, undergraduate and master's students. And we had a really good conversation around
you know, what does it mean to be teaching mathematics? And if we're going to honor the discipline and his belief in whether he thought all children would be able to think in the way the discipline requires. And we spoke a little bit about a very important dichotomy that exists in the teaching and learning of mathematics, and that's around the idea of correctness. And so you'll see here that his quote, as I read it to you, is addressing this concept of correctness in math, because math for a very long time has been about clearly right or wrong answers. And you might find his thinking very, very fascinating. So he said, "I must be clear that the ultimate goal in mathematics education should be for students to grasp some understanding of the idealized perfection which is the mathematical realm. This is an unforgiving place where there is no room for half-truths or almost correct answers. The payoff is the ability to experience in awe that the universe seems to favor mathematics everywhere, seems to speak in mathematical language. This gives a sense of ubiquitous connectedness, rivaling religious inspiration." He also goes on to say, "Or perhaps we can go after a humbler goal, individuals using critical thinking every day to make decisions that will affect their lives in the collective. This can only happen when students not only know how to get to the correct answer, but also understand why the applied method works. One critical aspect of learning and curiosity is that it is more interesting when the facts are not as obvious as expected. If mathematicians work on a problem which has a simple, obvious answer, then there is very little learning coming out of that experience. If, however, the simple and obvious answer does not work, then the problem is 1,000 times more interesting. There must be some aspect of the problem which requires deeper consideration. This is intriguing and new information will be derived from this. True mathematical discovery occurs in gray, non-binary areas of uncertainty. What is important is to train students not to fall into binary assumptions, but to keep an open, critical, and creative mind." So what I would like to do is offer you, again, and I'm going to limit this to 30 seconds, offer you an opportunity to think about the message that Professor Dr. Christian Rios is expressing in his quote. What is he saying about the importance of creating a thinking classroom in mathematics, even for primary students? So I'd like to give you 30 seconds to think about that. And thank you to those of you who are writing comments in the chat box. Please feel free to continue to do so. I try to read them as much as I can as we're working through the sessions, and you're sharing some fabulous ideas. So thank you for that. I want to add just very quickly around the quote from Christian Rios that in the work that we do in mathematics, even with our younger children, it is really important that from the very beginning, as we build those learning building blocks for our children in mathematics, so that they have the capacity to be successful over time in a sustained way, we do need to think a little bit about this balance between correctness and exploration and discovery. And I think what Christian has really said, which is really, really important to me, I know, as a teacher of mathematics and someone who is a mathematician themselves, the idea that, yes, mathematics is about truth and false, and we have to have our children exploring that concept in our classrooms, but it also is about the magic and the mystery of the journey that we take to develop an understanding of these beautiful concepts in math and the language of mathematics that is highly symbolic in nature, and therefore in itself is very, very magical. The next source that I'd like you to consider is one that identifies the science behind the learning of mathematics. And here, for some of you, you might be taking a look at this and wondering, I'm not sure what the heck this person is writing, but it is really about the neuroscience in the study of mathematics. And you'll notice here some of the key ideas that are being shared is this idea that repetition is really important for creating neural circuits so that information gets transferred into the memory and is maintained over time. But the other important aspect of the way our children need to learn is that mental manipulation and active processing of learned information through the executive function, the prefrontal cortex, which is really the thinking area of the brain, is also important because that is how the networks activate new information and engage on connecting their background knowledge with new information through prioritizing, comparing, contrasting, engaging in deduction and deduction, and in this case, stimulating the storage of memory that in a way that both has increased the depth and speed of that memory. So yes, it is really important that repetition, that again, we have a balance in our math class between what I like to call practice for proficiency, but that can only happen once the active processing and the mental manipulation of mathematical ideas has taken place. So again, what I'd like to do is offer you, and I think 15 seconds is probably enough because I do want to move to other areas, 15 seconds to think about what does this tell us about how important creating a thinking math classroom is for primary students. Thank you, Michelle, for the timer. It's very, very helpful. We're going to move on to the third source, and the third source is looking at the practical side, or what I like to call the practical side of learning mathematics. Because ultimately, what happens is many of our students, ultimately, once they leave your primary grade level, start to wonder, why am I doing this? Why is this important? And a lot of parents are saying, well, if my child is not mathematically minded, that's not okay. And what we really want to start thinking about is what learning of mathematics can bring to our students in a very practical way. You'll notice here that this is a graph that has been created by the OECD, and it shows very clearly that over time into the 21st century, over time, the nature of the work that our students are being asked to do when they leave our schools is very non-routine in nature, and it is non-routine, analytical, and interactive. In other words, what they're going to be doing when they enter the workplace is being required to responding to problematic situations that are unexpected on the spot, and required to think through those situations and interact with others in a collaborative way to solve problems. Given that this is the practical side of learning mathematics, I know for many of you, you're probably thinking, well, that's really, really far away from what my primary students are going to be doing. But again, reminding ourselves that the work that you do in primary is so central to building those really important blocks of success for our students in mathematics that will ultimately get them to this wonderful place where they want to be successful in life. So having said that, again, I'd like to give you 15 seconds. What does this tell you about the importance of creating a thinking classroom for primary students? The second last source is something that you may have seen before, and that's considering the value of challenge in the learning of mathematics. I think for some time what we've done in the teaching of mathematics and other areas as well is try to scaffold student learning so that they can be successful in a manner that, rather than encouraging them to think and take the challenge and the risk to think through and solve problems on their own in a way that empowers them, for what I would consider positive intentions, we've scaffolded things by breaking things down in steps and actually directing students and telling them what to do to solve problems. And if you look at all of our textbooks, even some of our most current textbooks that are supposed to be problem-solving in nature, they still break down problem-solving questions by giving a series of questions that tell students what they have to be thinking about, and sometimes even how they need to be thinking about it in order to solve problems. What this infographic is really expressing to us is that there's a problem with engagement in our classrooms that really fall within a particular element of engagement. And you'll notice here that they call it intellectual engagement. And this really supports the idea of the value of challenging our mathematics classrooms. What happens, and you'll notice here that in the younger grades, children are feeling intellectually challenged, but then that starts to decline as they get older. We need to continue to encourage all of our children to be intellectually challenged, to be cognitively challenged, so that they can be cognitively engaged. And so this is another important idea that we need to consider as we're thinking about how important creating a thinking classroom for our primary students is. So again, I'd like to give you, let's say, 10 seconds now to think about what is this telling us that might be important to help us justify or perhaps refute the need of thinking in our classrooms. Okay, I'm going to move forward, and many of you may have already seen this, but I think it's important for us to revisit. And it comes from the work of Carol Dweck and growth mindset. And it's a focus on the importance and the value of making mistakes. And Carol Dweck, in her work, has identified that there are 4 types of mistakes. And you can see in this graph that mistakes that are made with high intentionality
Laura, I think we are having problem hearing you. I don't know if... okay, yes, there was a problem with your microphone for a few seconds. I think you are back online now. Yeah, it's better. There was a problem with your microphone.
Thank you very much. Thanks, Michelle. So you can see here from this graphic that if mistakes are made with high intentionality, they lead to greater learning opportunities for our students. So yes, often our students make sloppy mistakes, but perhaps they're not as important for the learning of the students than mistakes that we call stretch mistakes. And stretch mistakes are those mistakes where we invite our children right from the very beginning to think about a problem that is really quite challenging, and they might not and probably do not know the answers to. Hopefully they don't know the answer to right away, but they have to begin thinking about what they might already be able to do to respond to that question. And we call the mistakes that they make, whether they're conceptual mistakes or mistakes related to their ability to use the mathematical processes correctly or not. These are the mistakes that actually over time encourage our children to stretch their thinking, to stretch their learning. And so these stretch mistakes are the mistakes that we want to encourage happening in our classrooms with our primary students. Now you'll notice that aha mistakes, those mistakes that children start off by saying again, by being given a really tough problem that they don't know an answer to, and after a little bit of time, given the opportunity to go back and reflect on it, they can say, oh, I think I just had an aha moment. I may have been wrong about this, but now I get this from the learning opportunity that I've just been engaged in. So there is high learning opportunities for aha moment mistakes as well, but stretch mistakes tend to be more powerful. And finally, you'll notice that the lower learning opportunities happen from sloppy mistakes, which just really come back to encouraging and nurturing our children to pay attention to details. And lastly, high-stake mistakes, which are really those mistakes where we tell our children that you know, they're going to be writing a test, they're going to be writing a quiz, or as they've been learning for a few days, now I want to see how well they do, without an opportunity to be thinking all along about the mathematics and the interconnectedness of everything that they do in math. And all of a sudden they feel like, oh, I have to show you what I can do and understand, and it seems to be like it's really important, and what if I don't do well? And all of the anxiety with high-stakes mistakes comes into play, and you'll notice that those are really low in terms of learning opportunities for the students. Now, Carol Dweck writes that it's important that all of our children understand the nature of these types of mistakes so that they can play a role and take ownership over choosing the most powerful mistakes as well, or feeling empowered when we as teachers provide them opportunities to make those types of mistakes. So again, I'd like you to go back to the question about how important is creating a thinking classroom with your primary students in light of Carol Dweck's work around the value of mistakes and the ideas that I've just shared with you around her work. And I'd like to give you 10 seconds again to think about that. So finally, I want to bring you to what's going to pull all of your thinking together and have you thinking about considering all of the different resources that we looked at, and we actually looked at 5, but you have discussed a lot of other really important ideas. I've noticed in the chat box, ideas like differentiation, ideas like math talk and having children working collaboratively, sharing their thinking. You might include those in some of the compelling evidence of what you believe is important in deciding how important it is to create a thinking math classroom for your primary students. So I'm going to have you, and I'm not going to give you time to actually do this right now because you've been doing this thinking all along and I've given you some time. And I also want this thinking to be a takeaway for you to consider as you watch your students, you watch them learn, and if you decide to implement some of the work that you see tonight and hear about tonight in this webinar, I'd like you to consider, keep thinking about what would you say in a 2-minute speech to either your administrator or to the superintendent or to a coordinator who's in charge of mathematics. What would you say about the importance of creating a thinking classroom for primary students, and what evidence would you choose? Now, I want to leave this with you, but highlight a few important things. And these are important things that I think were just modeled in what it is that you just did, but also important implications for the teaching and learning of mathematics. First of all, I think it's really important that inviting students to think leads to deeper, more sustained learning than simply having a requirement to recall content. As we saw in some of the quotes, having to practice for proficiency, repetition is really, really important. But repetition and proficiency can take place at the same time, in the same moment, as we encourage our students to think. Students can be engaged in a range of repetitive thinking opportunities and do what we call, as a consortium, thinking to learn as they learn to think. The two can happen simultaneously. Secondly, we want to provide students ongoing opportunities to revisit, refine, extend, and revise their learning, because that encourages them to not only self-regulate, and you'll see self-regulation is really important, and self-correct and become independent students. That's our ultimate goal, even with our primary students. But we also want to persevere. We want to nurture perseverance as well as self-regulation. And by having, just as you did, going back and thinking and going back and thinking again and again and again, it's important that we do that with our children in our primary classrooms in the math context. We also want to provide students learning opportunities that are going to sustain their learning. You noticed at the end, I didn't simply say to you when you looked at the ranking ladder, I think it's important now that we discuss this and see where you stand with this, but rather I invite you to continue to think about this as you gather more evidence in your classrooms as professional learners. And so I want the learning to be sustained. And as a result of encouraging the development of a thinking classroom, these types of things will happen very naturally in the classroom with your students. Lastly, I'd like you to consider how we scaffolded and used the tools for thinking in order to ensure that you were successful, and we need to do a parallel thing with our students. So for example, you probably saw very clearly that when I invited you to engage in thinking, it was a particular type of thinking. And it's a particular type of thinking that you noticed probably in the quotes that is natural and intuitive and important to mathematics. And that's what we call critical thinking. So when we talk about sorting, comparing, contrasting, to what degree things have relationships, engaging in induction, that is taking a look at examples of things and drawing out some generalized ideas or patterns from those things, or starting with a broader idea and trying to support them with evidence, with examples, induction and deduction, these are all the ways of thinking that define critical thinking. And they only happen if we do four really important things. You'll notice as you engaged in the critical challenge I invited you to engage in, I offered you a question and a task that had you consider various options. Is it of very little importance, somewhat importance, or great importance? You had to consider those options in light of the evidence that you were considering and gathering. You had criteria to help guide your thinking and filter through that evidence in order to help you ultimately solve the problem that I posed to you. In other words, to make a reasoned judgment or decision that is supported by all of those intellectual tools. So these are the types of things that we want to encourage happening to our classrooms. And noticing that content is also an important tool for learning, but not the primary goal for learning. You'll recognize that I asked you at the very beginning to access some of your prior knowledge or prior thinking, the things that you value as an educator, before we even started to engage in thinking. All of these have important implications for the teaching and learning of mathematics, which we're now going to explore. We're going to be looking at how we define quality thinking. And again, I'm going to invite you to be thinking about this before we start to explore this whole idea of what does it mean to be a quality thinker in mathematics, and what does it look like and sound like in a primary classroom with your younger children. And I'm going to invite you to think about what would children learning mathematics in a primary classroom be doing, thinking, talking about if we've created a thinking classroom. So imagine your classroom transformed so that there's thinking going on all of the time, every day, at every moment. What would your children be doing, thinking, and talking about? And just starting to think about what are the characteristics in terms of what they would be doing, thinking, and talking about. How would we define a quality primary mathematical thinker? And I want to give you a minute to start thinking about that yourselves. Imagine a classroom where thinking goes on day in, day out at every moment. What are your young children doing? What are they thinking about? What are they talking about? I want to thank everybody for sharing their ideas in the chat box. Really important and a great way for us to collaborate. I do want to make one small detail clear around encouraging your students to do this type of thing, your children doing this type of thing, and something that I failed to mention to you, so it's my fault. I failed to mention to you that when we invite our students or anybody to engage in their initial thinking, accessing their prior knowledge, one of the things that we want to do is we want to make sure that that stays private. The very first time, it has to be owned by the child in your classroom and not shared to everybody else. And I apologize because I should have made that clear. And it's okay because we're all adults in the room and it's okay that we're sharing. But I want to explain very quickly why that's important. And there are a few reasons, but they're significant reasons. The first is we want to encourage our children to take risks. And I know that at a very young age, it seems like that's not a problem most often with the young ones, that, you know, they're ready to dive in, they're ready to share, which is fabulous. But I've noticed also sometimes that still by the time we get to grades 2 or 3, the children are starting to feel like, I'm not very successful at math. I'm not sure I want to share my ideas. I'm not going to take a chance. And they start to put on that protective shell because they're not sure that they want to expose themselves to failure. So the first thing we want to do is make sure that this thinking, their initial thinking, stays private so that we encourage them to feel safe. The second reason is we really want this thinking, this pre-thinking that the children do and that you just did right now and that we're going to revisit over time as we go through the session today. I'm going to invite you to go back to this periodically. We want to make sure that the generation of ideas is truly owned by the individual learner. And collaboration is going to take place through the learning process, but ultimately, so a child can self-regulate so that they can truly fill in their own learning gaps. And by the way, this is something we call a launch, and we'll talk about it shortly. But as we have our children engage in a launch, where we launch their learning into a sequence of learning opportunities, we want that thinking to be owned by the student, and we want this to be a really powerful way to differentiate. Because what happens as the children go back and revisit their thinking after they've engaged in some learning, and then revisit again after they've engaged in some more learning, they're able to identify where they were at before and how they have to fill their own learning gaps. And this is how we encourage self-regulation and self-correction and independent learning from our students. So I just wanted to put that note in there because I think it's really, really important. Having said that, I now want to move us on to really I think the most important part of our work tonight is taking a look at what does this look like in a primary classroom? How do we create and promote quality thinking in a classroom full of primary students, full of young children? And I want to do this by sharing a number of examples with you. And I've got an example for kindergarten, grade 1, grade 2, and grade 3. Hopefully we have enough time to get through all of them. And as I walk you through the different examples, what I'd like you to be thinking about is what are all the features that every single example, no matter what grade level we had our young children engaging in the learning of mathematics, what are the features that all of these activities and the design of these activities have in common? And I want you to be thinking about that. And thinking about that, you'll probably also be thinking about, how are my students going to respond to this? What have I asked my students to do? What have I asked my students to think about? What have I asked my students to talk about? So those three areas are going to come through as I share the examples. Now this is a primary example, and I also want to encourage, particularly with the very young children, although I like to encourage it across the grades, but sometimes it gets a little bit more challenging to do. Not impossible, but a little bit more challenging. And if you're starting to do this work, perhaps as the children get a little bit older and your curriculum becomes a little bit more daunting, and we really want to focus on the mathematics, we might not be thinking about integration right away. But for our kindergarten and grade 1 students, it's really, really important. And I'm not saying that it's not important for all, but it's really important for really young children. So I want to show you here that as I introduce this task to you, you'll be seeing that we're integrating and we're beginning with encouraging our children to think critically by something that is authentic, an authentic learning opportunity that may not necessarily first appear to have anything to do with math, but we will make the connection to mathematics. So be patient if you don't see it. So here's the launch, and this is a launch that these kindergarten, very young children are being asked to participate in. And they're asked, how might this happy face make someone feel if they've been ill? And you'll notice that the happy face is designed to incite an emotional response, and that's precisely what we want them to be doing. Because this particular, what we call line of inquiry, critical thinking, is around encouraging our kindergarten children to be empathetic towards others, to understand the emotions of others. And it comes right from the curriculum. So we ask them to think about it, and we give them some options to consider. Notice the options come through. Would it make them feel happy, sad, scared? Is there anything else? So some children might say, oh my God, it looks like it's screaming, so it might be angry, or it might be frightened. So they come up with a series of emotional options. And then we ask them, well, if you had to draw a happy face for someone who has been ill to make them feel better, would this work? What would your happy face look like? So you notice right away, we engage them in a launch that we call a design launch. So right away, the students start designing and coming up ideas for a design of a happy face. And we then ask them, and we then tell them that our task is that we're drawing a picture of a happy face on blue construction paper because unfortunately I've come into the classroom today and that's all I have, but we have to make a happy face for a friend who's in our class who's been in the hospital and has been ill. And we have to figure out what would be the best color for that happy face. So I want you to think very briefly. Again, I'm going to give you 15 seconds. But remember we talked about the existence of options and criteria to help a child make a judgment, a decision, and here the decision is about the best color for the happy face. So what might be the options they're going to consider, and what criteria do you think they're going to think is important to help guide their thinking to make that judgment? So I'll give you like 10 seconds just to think on your own, and maybe this is where you can put your ideas in the chat box. Very important to share your ideas. So criteria, what criteria would the children be considering? What options? So perhaps, and I apologize, it didn't give you a lot of time to be thinking. Thank you for sharing your thoughts. What shapes can I use? Absolutely. So, but notice that with the questions asking them, and we will get to shapes, and so that's your mathematical mind coming through, so thank you, and I appreciate that. But you notice here we really haven't gotten to the math yet. We're just looking at color. And when the children did this, they're going to immediately, those of you who teach kindergarten, they're immediately going to say, well, I want to choose my favorite color. Of course I want the happy face to be my favorite color. And so they're going to throw out a series of options. So I like red, I like orange, I like green. They're all going to put out their colors. Some of the boys, oh, I want black. Black's my favorite color. And we have them essentially brainstorming all sorts of different colors. But now that we have all of these options to consider, how do we decide which of these options is the best option for the best color for a happy face? Noticing the context, we've got blue construction paper that we have to use. And I want to highlight another important piece because this is going to translate to mathematics. Much of mathematical problem solving is the result of constraints. And you'll notice here by saying we walked into the classroom and we only have blue construction paper, we've created a constraint. You don't have a choice around all the different colors you can choose to draw your happy face on. We've got a problem. There's only blue construction paper. And we have to draw the happy face on a blue construction paper because we need to send this happy face out to our friend who's in the hospital as soon as possible. So The children have generated their options, and they've done that very, very naturally. But you'll also notice that good critical thinking is not thinking that is driven by preferences. Now, this again has important implications for math, because a lot of the work that I've seen in many classrooms is encouraging students to think about how they would like to solve the problem, how they would prefer to solve the problem. And true mathematics is not preferential thinking, it's critical thinking. Remember the thinking that I just mentioned earlier on. So what we want to have happen here is ask the children, well, we've got a lot of favorite colors here, and I guess we could choose the favorite color of the young girl who's at our friend, the young girl who's in the hospital, but we don't know her favorite color for sure, so how are we going to make this decision? And so the children very naturally say, well, we have to choose a color that's going to make her feel good. It's going to make her feel better. Absolutely, that's a great idea. And then we have some children who say, and by giving them an example, so where are we going to put the card? Is she going to hold the card the whole time? No, we have to put her on the wall, or it's going to be on a table. So what else is important about the card? And they say, well, we have to be able to see the color from a distance. And you'll notice that the children come up, and we co-construct criteria with the children, and they come up with 2 criteria. And then we assess with the children each one of these colors in light of the criteria, in order to determine which one is going to be the best. Notice how the children immediately engage in some really, really, really positive, high-quality critical thinking. And this is what we call inductive thinking, because they're looking at various examples and they're thinking, how do I generalize this? How am I going to pick the one that I need to pick? Now, let's get to the math. Well, notice that, again, we encourage when they first drew their happy face. Now they've done some thinking around color. This is what we had introduced before. They had designed their own happy face, and we're going to ask them, so what would you change and add to your happy face in terms of color? Now we get to the math, and we ask them, how many different circle shapes will we need for the best happy face for our friend? Now notice there's a number of things happening here. We're highlighting and focusing on circle shapes. Now again, I'm going to give you 10 seconds to think about what options, if I'm asking them how many different circle shapes will we need, what are the options that they will be considering for different circle shapes in this context, and what criteria will they use in order to help them choose amongst the various options. I'll give you 10 seconds to think about it. Sizes, congruency, great ideas. And this is full circles, half circles, small circles, big, absolutely. This is exactly what the children said. So when we asked them, what are the different circle shapes you could consider, remembering these are kindergarten children, they immediately said, and this is their own language, small, medium, and large. So they looked at the measurable attribute of size in terms of the circles, and some of them actually did say half circles, quarter circles. And it's really quite impressive to see young children, kindergarten children, thinking about half circles. And many of them noticed that there was a half circle here, so they could make that connection. But to extend that to quarter circles was really, really quite powerful. So these are options they have to consider. These are the criteria they identified. Well, if I'm going to choose, I choose small, large, medium, half circle, quarter circles, I'm going to need them to be looking like the body parts I want to choose, and I'm going to need them to work together to make a face that looks like a happy face. And so as the children went through this and then they decided, they were invited back again to revise and take a look at their happy face and think about how they would revise their happy face based on circles and the different sizes of circles. Now notice here, there's a lot going on here mathematically. It's not just small, medium, and large, but the children started to think about how many, because the question was really how many different circle shapes. So you'll see here that they started to think circle shapes, and from here we would move on to another lesson where the children would start sharing all the different circle shapes and their happy faces and thinking about, as a class, if we're going to choose one happy face, what's it going to look like and how many different circle shapes. So they're going to have to sort them based on their attributes, and they're also going to have to count. So we've addressed quite a bit of the curriculum to have them work together in order to come up with the happy face design that the class is going to use in order to create a happy face for the child who's sick in the hospital. Now you'll notice here that in kindergarten, really, we want to be thinking about a little bit in the moment about, what children in the classroom are going to engage in. So we want to observe, what they're talking about, what they're thinking about, and make connections to have them think critically in the context of the things that they're already prepared and willing and interested in building and curious about, so that they can explore and discover in a way that's meaningful. I want to return back to the attributes of a quality mathematical thinker. What are some of the things that you noticed that the children were being invited to do that would characterize what a quality thinker, good critical thinker would do in a primary classroom? And again, I'm going to give you 10 seconds just to add to your thoughts. Thank you again, Michelle, for the timer. Very helpful. We're now going to move to grade 1. And what I've done with the grade 1 example is I've highlighted the curricular expectations that are going to be addressed through this particular series of critical thinking invitations. And really what I'm going to model for you is critical inquiry for grade 1, where these are the expectations that I'm hoping you're going to see are being addressed throughout the inquiry that I've invited the children to engage in. I want to also add, as you look at this, that, by the way, I'm sharing with you what we call lines of inquiry, critical inquiry invitations for children across the grade levels that we've used in classrooms. So you'll notice I'll talk about how the children responded, and that comes from the actual experience of implementation. So here's the task, and again, you'll notice we start with a lunch, and we give the children 3 circles that we say are defining play areas. So we have circular play areas, and really the shape of the play areas is not important. What you'll notice is that we say that in these play areas, there are different shapes that are used in the play area to help the children play safely and have fun. And you'll notice we put a little image there. We might show images of play areas that children can relate to. And we ask them, which do you think is the most pleasing play area to play in? And right from the get-go, we can say, here's the first play area. We might number it, number 1, number 2, number 3. And we ask them to circle or shade in or color in or put an X around or whatever you want to do, but indicate what play area you think is most pleasing, and think a little bit about why. And then after they've chosen, we spend some time talking about why. I want to highlight the thinking in this initial launch. And it's important to highlight the thinking because this is really what's important about what's going to support our children's learning in mathematics. We've asked the children by asking, what do you think is most pleasing, or what is most likely most pleasing, because that's what we've asked them to do. We're asking them to engage in the making of conjectures, and we want those conjectures to be made well. So we say that they're engaged in making quality conjectures, or in mathematics we would say sound conjectures, or engaged in sound reasoning. And you'll notice here that right from our mathematical processes, there's a direct connection to making and investigating conjectures. So here we go. We start off right away. We ask them to make a conjecture. And we want to talk a little bit about how did you make that conjecture? Now, this is where we ask the children, what did you think about? As opposed to, how did you do it? This is, what did you think about? How did you decide? Notice the difference, as opposed to how did you do it? Because a lot of children will start actually drawing pictures or doing what they can or circling things, and they're starting to think about immediately, how am I going to solve the problem? And this comes as a result of still a very strong focus on when you have a problem in math, you have to think about tools and strategies right away. And what we need to do in our math classrooms is pause for a moment, across all the grades, by the way, pause for a moment and have the students engage in some thinking where right away they don't see a right or wrong answer. Remember when Professor Rios talked about that journey of learning that is so important to mathematics, that brings out the mystery, the curiosity, the magic of mathematics. And this is how we get to it. We get to it by inviting students immediately to reason, to conjecture. So, talking to the children, what they end up saying is that, well, I noticed all the different shapes and I looked at the shapes and, you know, color was important to me. And notice when they're young, they're going to go with preferences. So color was important to me. So the shapes, I noticed the shapes. I noticed that there's different shapes. And if I'm thinking about pleasing, you know, some shapes are more pleasing than others because I like the colors more, or I like different shapes more than others. So they start paying attention to all the details, the color, the shapes, the nature of the shapes. And then they also start talking about what they already know about the shapes, because they've already started to explore the shapes a little bit in kindergarten. And with that, we construct some criteria for pleasing. So what does it mean to be pleasing? Oh, it makes us feel good. Okay, so which of these shapes do you think you'd want to jump into a play area in and will make us feel good, will make us comfortable? And immediately they say, well, color is important because the more colors, the prettier it is. Okay, so color is important. We want to have a lot of different colors. What else is important? And they start immediately going to the properties of the various geometric shapes and they've been asked to investigate. So they start talking about it in student-friendly language. Well, I noticed that, you know, some of them have more sides, and the sides might scratch us. And others say, well, some of them have more or less corners, and the corners will poke us and they'll hurt. And notice that what they're getting to is the mathematics around the number of sides of the shapes and the number of corners and the vertices of the shapes in a very natural way. So they're starting to engage in what we call the proving part of reasoning and proving, because they're starting to recognize some patterns, but not formally yet, because we haven't asked them we haven't invited them to do it formally. But then we do. We take each of the play areas and we say, how pleasing is this play area? And they use the criteria for pleasing, and we now introduce a thinking strategy, and we introduce some very clear options to help them decide. So is it very pleasing? Is it, you know, is it really comfortable? Would someone feel really good if they jumped into that play area? Is it a little pleasing, or is it not pleasing at all? It's horrible. I really wouldn't jump into that play area. And so the children we give them the pictograph, and we integrate graphing from another strand into what the children are doing. So now they're starting to get into that proving piece of reasoning and proving. They're starting to sort and starting to generalize. They do this several times. First, as a class, we explore how pleasing is the first play area. And by the way, I want to add, every time they've finished exploring each of them, they go back to their initial choice and we ask them, have you changed your thinking? Would you choose a different play area from the one that you chose before? Now remember, very young children are going to choose mostly based on preferences, and that's not what we want them to do in mathematics. We want them to choose based on their mathematical understanding and their mathematical reasoning. So now we do one play area, then we do the next play area, then we do the third play area. So now they're assessing their three options. And we go back, and again, finally, for the third time, they go back and we encourage further reflecting. Now you'll notice I'm making clear connections to the mathematical processing. Notice how important the mathematical processes are to invite students to engage in critical thinking. In fact, students can't engage in the mathematical processes without thinking critically. So now they're reflecting and they're self-monitoring. They're seeing that what they didn't understand before, they now understand more about, and they're changing their initial position. They're changing their second position, their third position, and they're all excited because all they're doing is chattering about how they figured out all this new stuff, and now they're like someplace else. They've changed their ideas. So notice that critical inquiry is really driven by the students being invited to continuously affirm, refine, revise, extend their thinking and their response. Notice the practice for proficiency. They're revisiting these ideas and reinforcing the learning and their conceptual understanding, again through further thinking opportunities. So now they're being asked to place the 3 different play areas in order from most to least pleasing. This kind of rating is really central to mathematics because most of you probably think, well, that's kind of a number line. It's a value line. It says most to least. So one of the things that you could do is very naturally integrate by putting numbers in here along the rating scale. But you'll notice that now the children are using the criteria and they're thinking, well, we've done our thinking around each of these. Now, which one as a class have we decided is most pleasing to least pleasing? Notice that the rating slide gets them to begin communicating very clearly using mathematical language, mathematical vocabulary, the appropriate use of representations, and their ability to organize their thinking. They've done all of this, and now they're able to really collaborate and share their thinking in a meaningful way. Notice that the thinking strategy we used here is they're using a rating scale. We then end, again, reinforcing for pushing their thinking forward, extending their thinking, and bringing them back to, can you, with a partner, make a play area that would now convince Anna to come play with us? Here, now they're engaged in representing. They're creating representations of a mathematical idea of a pleasing play area based on the properties of geometric shapes, making connections in order for them to solve a problem. Notice here that we've provided an opportunity to extend the thinking of some of the students. This is really important, even though this might not be, and I don't really care whether the students include the pentagons or not, but I want to see whether they actually can extend the pattern seeking and generalization that they've done further to the properties of other geometric shapes. And by the way, when the children did this, they not only thought about 5-sided figures, they thought about 6-sided figures, 7-sided figures. These are our grade 1 students extending their thinking beyond what we would really think would be imaginable. So I want to kind of go back to, again, the attributes that show you the clear connections to the mathematical processes, and I think I've made those explicit. But having you think about, and I apologize, just very quickly going back to the graphic organizer of the student in the center. Now what do you notice is very similar across, what are the similar features across the 2 examples that you saw, the kindergarten and the grade 1 example, and what does this tell you about the attributes of a quality thinker that we need to help develop in our primary students? What are the attributes of a good critical thinker for primary students? Again, what are they doing? What are they thinking about? What are they communicating about? And again, if you want to include your ideas in the chat box, that would be great at this point. I'll give you 30 seconds to think about this. Thank you to those who shared your ideas. Absolutely, a lot of exploring, discovery, investigations. In mathematics, we talk explore. You know, the word that we use to describe exploring you know, it is investigating. We want them to investigate. I noticed that the children, you said the children are coming up with theories, absolutely, mathematical ideas that they're testing, and they're seeing whether they make sense. All the mathematical processes coming into play. So thank you very much for sharing your ideas. Now I'm going to move to the grade 2 example, and I'm going to hope that I can get through also the grade 3 example before we close. Here we're going to be looking at really estimating, measuring, recording. We'll focus on temperature here. They're going to be reading, representing, comparing, and also what I didn't include here is the idea of benchmarks in terms of numbers and using benchmark numbers and locating whole numbers on a number line. We start again with a launch, and here's another opportunity. And by the way, this particular line of inquiry or critical inquiry was designed for a school of grade 2 students out in Alberta that were about 80% Aboriginal in nature. So you'll notice that there's a strong influence of Aboriginal art and Aboriginal images in the pictures that you're going to see. Now, it's not necessary that you have to do that, but it's a great opportunity to think about how you might integrate that conversation with your children. So now the children are being asked to place the pictures along the line to show the most likely temperature outside, from the coldest temperature to the hottest temperature. Notice again the wording of most likely. When you see the wording most likely, what we're asking the children to do is judge the better or best. We're asking them and inviting them to engage in sound conjecturing, good reasoning in mathematics. You'll also notice that I placed a number line in here and created a few benchmarks by putting cold and hot on the number line. And I also didn't place the number line in its very common traditional placement. Its orientation is slightly different. And by the way, I've done that quite intentionally, and you'll see through this line, I move the orientation of the number line quite frequently, and sometimes I do a bit of a gradual release around the benchmarks. So the children are offered all of these pictures. They're given the visuals on pieces of paper. They're given the number line in that orientation, and they're being asked immediately to place the pictures, and really it doesn't matter whether they're right or wrong. We just want them to start thinking about the thinking that they have to do. We want to pull out the metacognition, and that's the important part of the launch. And then we engage in the teaching. And some of you may have already seen this. What season is it in this picture? But we take a picture out of a children's narrative, one that creates some cognitive tension because it's not quite clear what season it is. Some people might immediately say that it is summer, some fall. Some students have talked about it being spring. That's okay. But what we want them to do, again, is explore the thinking. And we encourage them again to consider options. What are the options we want to consider? Let's talk a little bit about winter, spring, summer, and fall. And how do you make here a sound inference? So again, a sound inference is made by having the children say, I have to pay attention to everything, all the clues. Really, we're talking about evidence, but all the clues in the picture, because I don't want to ignore any clues, because if I ignore some of the clues, it might get me to making a poor overall judgment. So I want to make a really good judgment. So I don't want to ignore any of the clues. The tiniest clues are really important. And I also want to be thinking about what I already know and understand to be conceptually true. So what do I know about winter, spring, summer, and fall? And they use this metacognitive criteria in order to help them make a sound inference. And then we move them back to the line. Okay, you've learned a little bit about the seasons, summer, winter, fall, and spring. Does it help you now put your pictures along the line? And notice that the number line now is placed in a different orientation. I've removed cold and hot and simply placed the benchmark of warm in the center. And we start off and we talk a little bit about, together, collaboratively, one of the pictures. And we chose this particular picture with this group because it was painted by a Métis artist, so it had important Indigenous significance, and the students were able to talk about that, but also get to the math. So again, they go back and they redo their thinking. Now, the important part here is that the teacher, and this is, I think, the greatest challenge for teachers, because again, with all positive intentions, teachers want to jump in and help the students get to what they think is the right or wrong or the best answer right away. And what's really, really important is that we don't do that. What's really important is we let the children muck about and find their way. Remember that journey of discovery that is really inherently about the mystery and the magic of math that we want to encourage all of our children to share. So we get them to go back, and now we want to focus in on the math. So now we want them making some sound conjectures. They go back to the line, and we talk about, okay, so how do we make the mathematical decision now? Where do we place these pictures on the number line? And so now we again want to surface the metacognitive thinking, and the children already know, well, I've already looked at the pictures and paying attention to all the details in the pictures. I know that's important to making a sound inference, and they begin to realize that the metacognition required for sound inferencing is exactly the same as the metacognition required to make sound conjectures in math. Okay? Sound conjectures being, I can't possibly know with the given information what the right or wrong answer is, but I can make the best possible judgment in light of the evidence that I have and the criteria that I need to use, the evidence, and what I already know and understand to be true. So now the students need to think about, what do I already know and understand to be true about these temperatures, the number line, and the concepts of cold, warm, and hot. And what I didn't build in here is a lesson now that gets students to go to some really nice narratives around temperature, cold, warm, and hot, and how do you know what it is. And there's a story about a young boy who goes out and can't decide what he's going to wear because it's so cold outside, and somebody else he knows doesn't think it's that cold outside. But anyway, so we use the narratives in the story, and we start getting through the narratives. We get to the understanding of cold, warm, and hot, and how these numerical benchmarks might help them understand this idea and how we use our number sense to understand the idea of temperature. So they go back and do this, and then we ask them to go back and do their thinking. Now notice, now we give them a choice and we say, you've got all of these images, and now you can orient your number line any way you want, because what we want them to see is, what we want to see from them is that they understand the number line, they understand the benchmarks, they've used visual representations and the concepts of seasons, warm, cold, and hot, to help them arrive at the best sorting and the placement and ordering of these pictures along the number line to reflect their understanding of temperature. Again, going back to thinking about what are the mathematical processes you saw at play, what are your thoughts around the mathematical processes? What did you see? In the chat box, share some of your thoughts. What mathematical processes did you see the students needed to engage in order to successfully complete the task? Fabulous. Thank you for sharing. I'm happy that you're seeing so many of these coming into play in this particular line of inquiry. They were all very important. Students were constantly reflecting, encouraged to reflect, going back, changing their response as they developed a deeper understanding of the concepts. They've developed their reasoning abilities. They've gone back and changed their response. They're sharing and talking and using mathematical vocabulary, benchmarks, numbers to share their thinking, engage in collaboration. They're making connections between everyday concepts, different representations, visuals, and the mathematical representation of a number line. So they're representing a lot of ways, connecting a lot of ways. They're reasoning improving throughout. And I would say ultimately problem solving for sure. So I just noticed, can anyone connect this to representing? So I hope I did that for you, that the representing was around making connections between the visual representations, the number line as a representation, so pictorial representation to a numeric representation on the number line, the use of benchmarks, and connecting those two together. I want to quickly go back to, again, is there anything that you would like to add? I invite you to add that, but I really want to get to my last example, which is the grade 3 example, which focuses on properties and relationships and patterning. Here is a line of inquiry around the concept of congruency. So we start again here. Now we're working with grade 3 students. We start with, again, a conjecture. Notice that every launch invites a conjecture and, along with the question, the possibility of a design. So if there's time for a design, I encourage it happens. Perhaps not a design right away. The concept is a little bit complex for the students. So you'll notice here students haven't been introduced to congruency at all. It's a big, messy word. The first thing that the students say is, oh my God, I don't know what is congruency. I don't know what that word is. But we want to encourage them to look at the different representations. And by the way, this was very intentionally designed to look like a multiple choice question, A, B, C, or D, because as we know in grade 3, students are getting prepared to write the EQAO. They're to write the EQAO test where they're going to face a lot of multiple choice questions, and we want them to recognize that multiple choice questions require critical thinking in order for the students to perform proficiently on them. So we ask them what makes the best, most plausible or reasonable choice. I know you don't understand congruency, but do the best you can. So as we encourage them to do the best they can, they start looking at the shapes and they start talking about, oh, it's in each of the pictures, there's similar shapes being used, so I think congruency is the shape is the same. So they come up with some ideas, and that's really what we want them to do. Anything, any idea. Again, you'll notice that what we want to encourage is even if I have a student who doesn't really quite understand, I want to encourage them to choose one. I don't care if you just chose it really quickly, you didn't think very much about it, because what will happen is when we return to it again, in order for them to engage in some reflection, when we return to the same question again later on, they look at their initial choice and they have to wonder, why did I choose that? And that's really what's important. And even if they chose it just randomly, they're going to have to say, I had no clue why I chose that. I chose that randomly. Now I better think about it because I just learned something. So really important that we give them something that's simple enough for them to actually just be able to choose. So you notice a lot of the examples, choose A, B, C, or D, color in a picture, choose one of these. So the options are really inherent and we want them to choose an option. We now want them to uncover the thinking that they have to do. So we ask how similar or different are these two designs, these composite shapes. We use a dashboard. Again, notice even in this small activity, there's always critical thinking involved, critical thinking all the time, options. If I ask the students, can you just list all the similarities and differences? They're just going to give me a list. They'll look at the pictures, they will look at the evidence, but they will not have made a judgment. What we want them to do is really pay close attention to details and really think deeply about what's going on. So we offer them a choice, very similar, somewhat similar, not very similar, and we say, so which one do you think it is? And we move around the arrow and we say, you choose one, you draw the arrow where you think it is. Let's talk about it. Because remember, now we're in the lesson part, so The launch is really owned by the individual student. The lesson part, they can share and generate ideas collaboratively. And they decide, then we look at another. And you'll notice here that what we've done is we've embedded shapes that students designed previously in the grade 3 class as a result of this lesson. So it's really fun and interesting, and we tell the students that, by the way, these were designed by the students who did this last year. So just, pretty neat, right? And they do the thinking again, and now we transfer that thinking that they do behind how similar, how different, the decision they needed to make. So again, how similar, how different requires them, we call this a decode the puzzle, and you'll notice when students make a conjecture or they look at how similar or how different something is, they're decoding, and the metacognitive criteria for decoding and conjecturing is always the same. They have to pay attention to all the details, and they have to consider what they already know and understand about the concepts at play. Really important for all mathematical thinking, and reinforced all the time. Now they get, and they work in small teams, and they get cutouts of the following sets of geometric figures, and they're asked to sort them into 2 different groups, and only 2 different groups, and they have to make sure that everything that they put in each group shares all the same properties. Now, of course, the students right away say, oh, what is a property? I don't understand a property. And again, we want to encourage them to be thinking about, so what do you think I mean by property? If I'm getting you to sort them into 2 groups and they all have to have the same something, what would it be? And so they say, well, and they start talking about the different things. You're right. It's kind of like characteristics, but in math we talk about it as being a property, something that holds true all the time, given those particular shapes. So we get to mathematical truth here now, which is really, really important. They sort, and they start defining what properties did each group possess. They start labeling, listing their properties. And this is the thinking template. What are your properties? What's the mathematical evidence that you have? Then they go back to their initial thought, and now they start choosing very, very intentionally based on what they've just learned. Okay. Then they're given another question. Josh says that image number 2 most likely represents congruency. How reasonable is his selection? So if he chooses B, is that a reasonable selection? So we start talking about B as potentially what we've done is used B as a tester, something that will push the students thinking a little bit more deeply. We give them additional testers to think about, and you'll notice here we very intentionally put transformations in this set of images because the underpinning conceptual understanding around all transformations is congruency, and often students do not understand that. So when they start transforming shapes, if they're asked to actually draw them, not just simply move them, but often even when they're asked to move them, to reorient them, they change the actual size of the shape. And it's really important that we bring home the idea that when we do transformations, the shapes remain congruent. They go back to their list. We share the list, talk about the evidence. They go back to their choice once again. We ask them, is this a good design to use to illustrate the concept of congruency? They work in small teams again. They deconstruct. This, by the way, notice how what we've done here is we've moved from this activity, which is induction, moving from specific examples to generalizations, the properties, and now in this task, we're asking them to engage in deduction. Now you've got an image. How do you deconstruct it? Where you pull out the examples that show you the idea of congruency. So in this particular line of inquiry, we're encouraging students to engage in deduction and deduction. Then they go back, and this is their final response. Can you select and defend your final choice? In the end, the teachers then, I'm not sure I put it in here, but at the end of the lesson, the teachers encourage them to design their own set of shapes to represent either very little, a small degree of congruency, to show shapes that show various degrees of truths in terms of congruency. So if I were to ask you here, because last time, well, I don't think I'm going to spend some time here, but just very quickly, sometimes when we plan our lessons, we want to be thinking about what is the dominant mathematical process that is at play. And here what I demonstrated for you is actually a line of inquiry that focuses on the development of conceptual thinking. And when we get together again for part 2, we're really going to look at conceptual thinking a little bit more deeply along with assessment. But what's really important here around conceptual thinking is the reasoning and the proving and the making connections as the 2 most important mathematical processes. So sometimes we do decide to focus, even though they all come into play, we really want to make explicit which mathematical processes are coming into play when we do these. So maybe we choose 1 or 2 that we want to highlight for the students. We're going back before we close to defining what quality thinking is. So I'm going to ask you very quickly, again, if you were to summarize, what does a really good quality critical thinker do? Can you tell me what are 2 or 3 in the chat box, 2 or 3 things that you would say? Let's say what are the 2 or 3 most important attributes of a good mathematical quality thinker? And I'm going to give you about 30 seconds to put some thoughts in the chat box for me. Thank you very much for sharing your thoughts. You've really, really captured really the sophistication of what we're asking children to do and the real possibility that our primary students can actually engage in this type of thinking. I'd like to summarize before we close the different keys, some important ideas I want to leave you with to think about, and the really important ideas around inviting students to engage in critical inquiry in the primary math classroom. The first thing is we want to problematize everything. We want to make critical thinking a routine part of daily learning. It can't be something that happens once a week, say on Fridays. It has to be something that the students do on an ongoing basis so that we have them thinking to learn so that they learn to think. We want the 2 happening simultaneously. Proficiency is developed both procedural, algorithmic, computational competencies are going to be developed in conjunction with their ability to think critically, collaboratively, and creatively. Secondly, we want students to continuously going back to where they started to affirm, revise, extend their thinking so that they're continuously growing their learning and they're in charge of their learning. And lastly, we want to always plan with an iterative structure in mind. So we start with a launch that is a critical thinking invitation that reoccurs throughout the learning process, the children can keep going back to. We want the structure to be a transparent roadmap for children so they're constantly making connections between one critical thinking lesson to another critical thinking lesson or opportunity, and they're building on that and going deeper and learning more and extending. And we really want to provide time for thinking that is both generative and constructive. Notice that the generation of ideas is really important because students have to be able to identify options. They can't identify options without the generation of ideas. The constructive part of that is then to take those ideas and choose the ones that are most mathematically sound. And we want to encourage them doing that by experiencing, making mistakes and experiencing some failure as a productive way of learning. I want to close by just reiterating the 4 attributes of critical thinking. This is where we're going to move to when we talk about assessment. So there are 4 things we always want our students or children to be doing. The black is kind of a checklist of what they would do. The red shows the level of quality. That indicates the level of quality that they would do it at in order to show proficiency. And lastly, I'd like to highlight just our critical thinking framework and identify that what we really focused on today was create opportunities for thinking, and through critical inquiry, encourage children to build the capacity to think. We did play with a number of the intellectual tools. We played with background knowledge. We played with criteria for judgment very, very clearly in all the tasks. You saw thinking strategies being embedded in the tasks. These are the 5 intellectual tools that we want to nurture in all of our learners so that they can become proficient critical thinkers. And finally, I want to leave this as the most important key to critical inquiry, is that we want to ensure that we understand that the power of inquiry does not lie in the asking of a single question, but the careful sequencing of lessons so that we sustain inquiry. We want to invite our children to think to learn so that they can learn to think mathematically. I'd like to thank you all for giving up an hour and a half of your evening. I hope it was a valuable session for you. I really appreciate your time, and there was a large number of us, so we really navigated an hour and a half together online very, very smoothly, and thank you to you for that. I hope you have a wonderful evening, and I look forward to seeing your names back in the main room for our next section, which I believe will be March 8th. Hope to see you then. Have a good night, everyone.
Yes, March 8th indeed. Thank you so much, Laura. Thank you for sharing your enthusiasm and taking us along such a wonderful journey of discovery. I really love the way you convert particularly complex concepts into concrete examples and situations that we can all relate to. This was again a great session of extremely high level of creativity and participation. Thank you all for sharing so many ideas and chatting with each other along the entire session, and thank you as well for answering each other's questions. That was really fantastic. As usual, at the end of one of Laura's presentation, I tend to feel both enriched and also, I must confess, slightly humbled. However, the key concept I will definitely take away from Laura's presentation this evening is that mistakes are highly desirable. And in all honesty, I never thought I did possess such an extraordinary aptitude to mathematics. Let me share a few things with you. We have a particularly rich program this season with OTF Connects. Let's have a quick look at some of the sessions we have planned for the coming days. This Wednesday we have an exciting presentation on spatial reasoning by Matthew Aldrich. On February 16, a presentation on using technology in kindergarten by Anya Kitchen and Kerry Daniels. I don't know them. They are new to OTF Connects, but that seems to be an exciting session on February 16. On March 2nd, a presentation by Maria Van Vallis on critical math inquiry, a similar subject, I guess. She's one of our most talented young facilitators. I have moderated for her in the past, and I always enjoyed her presentations very much. And then last but not least, Laura will be back with us on OTF Connects on March the 8th for the second part of today's presentation. This session was just moved from March the 6th to March the 8th and has not yet been entered in our calendar. So please remember to register in a few days. And I'm going to provide you with the links to the calendar and to the past resources. I'm going to paste them into the chat box for you guys. Here they are. I also would like to tell you about another opportunity provided by OTF and the Ministry of Education. If you are a qualified teacher and completed an additional qualification course in math, technology, or kindergarten, you may be eligible for a $450 subsidy. And here's the link to our website where you can get more information about applying for, sorry, I sent the wrong link, my mistake. Here it is. Oh, no, it's the right one, sorry. So there's the link for applying for that subsidy. 2 more slides, we're almost done. As you know, we need feedback from our participants. It's very important to us. When quitting Blackboard, you will be presented with the opportunity to give us your feedback on tonight's session and fill a short online questionnaire. The survey only takes a few minutes, so if you could do it right after the session, it would be greatly appreciated. You should be redirected automatically to the survey page when quitting Blackboard. As a new feature of our webinar, OTF would like to offer you as well a small bonus as a token of appreciation for your participation tonight. Once you have completed the feedback questionnaire, you will be redirected to another page allowing you to enter your name, and you will then receive a certificate of participation to this training session that you will be able to add to your professional learning resume. Please note that the certificate of participation is only available for 48 hours following this session. If you don't have the time to complete the survey right now, or if you missed anything tonight, don't worry, we'll send you a follow-up email and you will be able to do it later. And I will also provide you with the links that you need in order to fill up that survey and apply for that certificate of participation. I also would like to provide you with the link to the resource page for Laura's presentation tonight. It should be live by tomorrow morning. So here is the link. It's not live yet, but it should be live tomorrow. So that's it. Finally, I would like to invite you to follow OTF on social media as well as on our OTF website. I will now end the recording of the session. Please feel free to remain online if you wish to ask Laura additional questions once the recording has ended. Otherwise, I wish you all a very good evening. Thank you once again for your participation in tonight's session. We hope to see you very soon on OTF Connects. Bonne fin de soirée à tous et à tous. Merci beaucoup.